Hi dear students, today we are discussing matrix method. This is a method to solve a system of linear equations. Matrix method can be applied to solve system of linear equations in two variables as well as three variables. I am discussing here this method to solve a system of linear equation in three variables. Let us solve a system of linear equations. Let us consider a system of linear equations a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z is equal to d3. Now let us see how such a system of linear equations can be converted into matrix form. That's we named as matrix equation. So the above system of equations can be expressed as an equation as using three matrices. See the first matrix, it is a 3 by 3 matrix. Can you identify the elements? A1, B1, C1. They are the coefficients of first x, y, and z in the first equation. Similarly, A2, B2, and C2 are the coefficients of variables in the second equation. Very similarly, A3, B3, C3 goes as coefficients of x, y, z in the third equation. Therefore, the first matrix is constituted using coefficients only of the variables. That is why first matrix, that 3 by 3 matrix, is named as a coefficient matrix. See the second matrix into x, y, z, which is a column matrix of variables only. What are the included variables here? X, y, and z. Therefore, the left side of the complete equations is rewritten using two matrices, one of order 3 and second is of order 3 by 1, is equal to right side again it is a column matrix which is a matrix of constants. RHS is a column matrix of constants. For the given system of three linear equations is converted into matrix equation using three matrices. Let us say it is AX is equal to B, where A stands for coefficient matrix, capital X means the column matrix of variables is equal to capital B, where B stands for the constant matrix, column matrix D1, D2, D3. From this, you can find X. What is our aim? We want to solve, means we want to find the values of X, Y, and Z. So we can write that capital X is equal to A inverse B. That is why in the last session, we studied about inverse of a matrix. So here, to solve a system of linear equations, we will first of all express the linear equations in the form Ax is equal to B, so that X is equal to A inverse into B. For to solve a system of linear equations, the primary thing is to find the inverse of a matrix. Let us solve a problem. Solve the system 2x plus 3y minus z equal to 5, x minus 4y plus 2z equal to minus 1, and x plus y minus 3z is equal to minus 6. Watch carefully. What we have to do is we will express this as matrices. Using matrices, the above system can be expressed as, see, Ax equal to B. What is A? It is the matrix of coefficients. What are the coefficients? Yes, here it is. 2, 3, minus 1 from the first equation, 1, minus 4, 2 from the second equation, 1, 1, minus 3 from the third equation. Into column matrix of variables, x, y, z are used here, equal to, see the right side, the constant matrix, a column matrix again, 5, minus 1, minus 6. So we have A, X, and B. What we are going for is to find A inverse. For that, what you have to find first is determinant of A, because the existence of inverse of a matrix depends on determinant. It should be non-singular. Therefore, we are finding determinant of that 3 by 3 matrix. See the evaluation process. Here I expanded along first row. You can expand along any row or column. By expanding and solving, we reach at determinant A equal to 30. You have to write these two lines. It is not equal to 0. Therefore, A inverse exists. After finding determinant A, next is to find adjoint. We have the given matrix A. See the matrix 2, 3, minus 1, 1, minus 4, 2, 1, 1, minus 3. Therefore, adjoint A, you have to find the cofactors of each and every element, form the cofactor matrix, and write the transpose to get adjoint of A. Here I wrote it very directly. See the first element. What is the cofactor of first element A11? That means 2. Means you suppress, you hide the row and column that 2 contain. First row and first column suppressed, remaining a 2 by 2 determinant minus 4 to 1 minus 3. That means 12 minus 2, 10. Since it is A11 element whose sign is plus, the per element in adjoint A will be 10. Similarly, here I found all the 9 cofactors and transpose to get adjoint A. Now, then immediately I am using the equation A inverse is equal to adjoint A. It is I wrote 1 by 30. What 30 was? Determinant A. So I wrote in this manner. You have to write in this manner. Adjoint A the matrix and 1 by determinant A. Don't take that determinant A inside the matrix. Let it be outside itself. Okay. 1 by 30 of adjoint A. So we have A inverse now. Directly we are solving. We have x is equal to A inverse into B. That is x equal to A inverse. We substituted into B. 1 by 30 I am keeping outside again into multiply those two matrices directly. A 3 by 3 matrix into 3 by 1 matrix. Resultant will be a 3 by 1 matrix. Proper calculation and simplification. Finally I reach at a column matrix. Column matrix 1, 2, 3. What x was? Column matrix x, y, z. Directly you can write. Thus, the solution of the given system is x equal to 1, y equal to 2, and z equal to 3. Right? Here we solved this equation just because determinant A is not equal to 0. A was non-singular. If determinant A equal to 0, at the spot directly you write A inverse does not exist, therefore no solution. Right? In this way, you try to solve all the remaining questions.